Ever catch yourself taking numbers for granted? We use them every single day, but have you ever stopped to think, what's the story behind these symbols? Well, get ready, because today we are diving headfirst into the fascinating world of number notation. And to guide us on this journey, we're using these excerpts you sent over from TMM Complex Number Notation,
Why?
week 2.
I've seen this one, yeah.
Yeah, and let me tell you, it is blowing my mind.
Yeah.
Seriously.
It's amazing how this document connects something as seemingly basic as number notation to these broader concepts, almost like it's a secret code to understanding, well, everything.
Right, and they jump right in, too. No messing around. They go straight to the heart of it, the significance of zero. They're like, hold on, zero's not just nothing.
Yeah.
It's fundamental.
It's the building block, for everything in math.
It's like they're saying even nothingness has a voice.
They even connect zero to this theological idea of creation ex nihilo.
Okay, what is that now?
Creation from nothing. Zero lets us build these complex systems from nothing. It's like the foundation on which all of mathematics rests.
It's not just a zero. This is a whole perspective shift.
It is.
Speaking of perspective shifts, I love how this document uses this metaphor of a math map to explain number notation. And I'm a visual person, so that just immediately grabbed me.
The math map, yeah.
A math map, yeah.
It's brilliant because it visually shows you how all these different areas of math connect. Like continents on a globe.
Yeah.
So you've got your starting point, right? Number notation. But then you can venture out, into algebra, geometry, you name it. It's all connected.
Yeah. It's like you're not just learning isolated facts, you're understanding the whole landscape, the connections between everything, which is way more interesting than just memorizing your multiplication tables.
It is. Way more engaging, that's for sure.
It's a journey, not a destination, right?
And exploring a new continent, there's always something new on that map.
Now, can we talk about these diagrams, though? Because they use a bunch of Euler and Venn diagrams in here.
Oh, yeah, the diagrams.
And I'll admit, sometimes I get those two mixed up. What's the difference again?
It's a common point of confusion, but the document actually does a pretty good job of highlighting that key difference. Imagine, for example, you're trying to sort through all the movies that you and a friend have both seen.
Okay.
Yeah.
Okay.
An Euler diagram would only show the overlap, like where your tastes actually intersect.
Gotcha. So if we both love sci-fi, that's our overlap.
Exactly.
Even if I'm way into Star Wars and they're all about Star Trek.
Exactly. It's that shared space.
Okay, so where does the Venn diagram come in then?
So the Venn diagram, it shows all possible intersections, even if they're empty.
Oh, okay.
So there'd be a space for movies we both dislike, even if we haven't found any yet.
Right.
It covers every theoretical combination.
So it's getting more theoretical. Okay, so Euler is about what is.
Yeah.
And Venn is about what could be.
Precisely.
Oh, cool.
Euler is grounded in reality.
Got it.
Venn is exploring all the possibilities.
Okay. That actually makes perfect sense. Now, this next part is where I always feel like I'm like, wait, what? Base systems? I get that we use base 10, decimal system, whatever. But then this document's diving into base 2 binary code. It's like I walked into the matrix.
Like the secret language of computers.
Yeah.
But once you wrap your head around the basics, it's actually really elegant.
Is it really that simple, though? Just like zeros and ones?
That's it. Just zeros and ones. It all comes down to place value, just like base 10. But instead of hundreds, tens, ones, you've got 8s, 4s, 2s, and 1s.
Okay.
Because each position represents a power of 2 instead of a power of 10.
It's like you're translating a whole different language,
but
with just those 2 digits.
Yeah, pretty much.
It's really making me think about how much I just assume about numbers, I never even thought about how many different ways we represent them beyond just our usual 1, 2, 3 numerals.
It's easy to forget that numbers themselves are kind of these abstract concepts, right? Like 5, it's just a symbol.
Okay.
It's just like a convenient shorthand we've all agreed on.
Right.
And this document, they actually list out all sorts of alternatives.
Yeah.
You've got your Roman numerals.
Right, yeah.
Tally marks.
Yeah.
Even just like the way we speak numbers, right? Like 5 versus 5th, those are both representing a number, but in different ways.
But, when would you actually use these different forms? Is it just historical context? You see Roman numerals on a building?
Well, yeah, sometimes it is about the context, but it's also about picking the right tool for the job, right?
Okay.
Roman numerals, they look cool, they're elegant, but imagine trying to do like long division with Roman
Oh
numerals.
my gosh.
You know,
Yeah, no
you'll
thanks.
be there all day. Tally marks, great for like quick counts.
Right,
But if you're dealing with huge numbers, it gets really messy.
right.
And then you've got things like scientific notation, which is like, it has this place when you're dealing with these like astronomically large or tiny values.
Right. Okay. So it's about having the right tool for the job. And speaking of the right tool for the job, they throw in this concept of absolute value.
Oh, yeah. Absolute value.
And I'll be honest, I always kind of stumble over that one.
Yeah, it's often misunderstood.
Yeah.
People think it's just about making a number positive or something.
Right.
But it's really more about distance from zero,
Oh, okay.
regardless of direction.
Okay.
So think about it this way. Imagine you're mapping out city blocks. You wouldn't say a block west is somehow less distance
Right.
than a block east. Right.
Okay. That makes more sense. So it's like the absolute value of -5 and 5 is both 5.
Exactly.
Because they're the same distance away from 0 on that number line.
Yes.
Even if they're in opposite directions.
Exactly. A simple concept once you visualize it. But it trips people up because we tend to associate negative signs with being less than.
Yeah, that's true. Are there like areas of number notation that are still kind of like mysterious?
Oh, absolutely.
Yeah.
Yeah. And that's what's so exciting about math. It's not like a finished book. It's this ongoing exploration. Even something seemingly basic as prime numbers, right?
Yeah.
Still holds mysteries about their distribution, their pattern.
Oh, I saw prime numbers. We figured that out ages ago. The building blocks.
Right. But there's still so much we don't know.
Really? So even something that fundamental still has unknowns.
Oh, absolutely. And then you have whole new systems of numbers being developed all the time.
What?
With applications in theoretical physics, computer science.
Wow.
It's like discovering new continents on that math map all the time.
That's both exciting and kind of intimidating at the same time.
It is. It is.
But that's the beauty of learning, right? Like, there's always more.
Always more to discover.
Like dimension, because they don't just talk about length, width, and height.
Right.
They're going into 0-dimensional space, 1-dimensional space.
It can be a little mind-bending. But think about it this way.
Yeah.
You got a point.
Yeah.
Right? That tiny dot.
Hmm.
No dimensions. It just exists.
Right.
It's just a location.
Okay.
But then you stretch that point out into a line. Now you have one dimension.
Okay.
Length.
Gotcha.
Extend that line, make it into a flat plane, boom. Now you have 2 dimensions,
Okay.
length and width. And finally, you add height, and you're in our world,
Yeah.
our 3-dimensional world that we experience.
3D. Okay, I'm with you so far. But where do these extra dimensions come in? Are we talking parallel universe stuff here? Is that what's happening?
It can feel like that. Mathematicians use higher dimensions to model complex systems
Okay.
and relationships that are really hard to wrap your head around.
Yeah.
In our simple 3D world, think about GPS
Okay.
relies on calculations
Mm-hmm.
involving time as a 4th dimension.
So time is a dimension. See, this is what I'm talking about.
Time is a dimension.
And I thought this was just going to be about numbers on a page.
It's so much more than that.
Right.
Numbers are just the beginning, really.
Okay.
This is kind of saying that they're the key to unlocking a deeper understanding of reality itself.
I can see that. Okay, we have covered a lot of ground here. Diving into all this number notation stuff, there are all these different ways to represent numbers. It's not just about the numerals.
Numbers are just ideas, really. Concepts. And the symbols we use, Roman numerals, tally marks, even just words, they're just different ways of expressing those ideas,
So then it's, okay, when is it better to use one over the other? Could you imagine trying to balance your checkbook using Roman numerals? No way. So each representation has its own strengths and weaknesses, right?
Absolutely. Roman numerals, elegant, but not very practical. Tally marks are great for a quick count, but good luck using those for some massive calculation. And then you've got things like scientific notation, which is perfect for those really huge numbers or those super tiny numbers.
It's about choosing the best tool for the job.
Exactly.
And the more tools you have, the better.
When you understand how numbers work, you can make sense of information so much better. You see patterns, you make smarter decisions.
For a minute there, I thought this was all getting a little too abstract. Like, when am I ever going to use this?
Right.
But then it hit me. We use this stuff all the time
All the time.
without even realizing it. Like when you're coding, building a website, Even just explaining something complex to someone,
It all comes back to that foundation.
it all comes back to logic and systems. And that's what number notation is, really.
It's the framework.
It's about thinking critically.
Problem solving.
Those skills that you use in every part of life, not just in a classroom.
Absolutely. It's about setting them up to be analytical thinkers, to tackle those big, messy problems. And it's never too late to start. Whether you're, in school, working, or just curious and want to feel more confident with numbers, diving into this stuff is a game changer.
Who knew that numbers could be so surprising and so interesting?
There's always something more to learn, no matter how basic you think a subject might be.
That's the truth. So, to everyone listening, I hope this deep dive has inspired you to open your mind a little bit to the world of numbers.
Make flying through the universe in PH88, where we're going, we don't need roads, don't even